Good? Yes? Time? Okay, so show of hands real quick. How many of you feel real good about that? Good? Yeah? Okay, how many of you, when you're doing your angles, are you counting around the way that I showed you how to count? If you don't, you're not going to offend me. Okay. All right, what I want to do here is I want to collect them, and I'm going to hand them right back out, but I'm going to scatter them around the class, and you're going to grade them. So you're gonna grade each other's quizzes. Are y'all gonna be upset by that? I'm not gonna.
I don't want them to know.
Do you not want people to know your grade?
No.
Really?
Yeah.
So I'm not gonna be able to do this?
I just don't want them to see my name.
All right, well then. All right, I won't do it then. I'll just collect them. Yeah, I would take them. No, I said don't do that.
Okay.
Yeah. Okay. I'll have my Cal 2 class grade them. They won't be as nice.
Then can I erase my name?
No, I'll grade them. Is that everybody's? Yes? Okay, I don't need to show you the unit circle, right? I mean, you can go, you'll know when I hand this back whether or not you got it right or wrong. Okay, now, today what we're going to do is we're moving into the next section. We're going to talk about the graphs of the sine and cosine function. All right, up to this point, we have 3 different ways we've defined the 6 trigonometric functions, right? We had, what are the 3 ways? Let's just review it real quick. The first definition of sine, cosine, tangent, right? The first definition that we had was a right triangle, theta, and then, we call this side the adjacent side, opposite side, hypotenuse, and then we defined all 6 trig functions based upon this, SOHCAHTOA, right? What was kind of the downfall of this? Like, what was the bad part of this? Yeah, you could only do it when the angle was less than 90 degrees. Okay, so even though it was good and SOHCAHTOA, that's all cute, we still had some limitations, right? So then what we did is we said, look, instead of doing that, let's just do the second definitions came from just take a point in space, right? Let it have an x and a y coordinate. Any point, right? Any point on the plane. And then if we measure the distance from here to here, we call that r, and we call this angle theta, then we defined all 6 trig functions, right? Sine of theta is, in this picture, y over r. Cosine of theta is x over r. Tangent of theta is y over x. Okay, and then all the reciprocals. So this was good. This is actually this is like the most general, most powerful formulas or equations for the trig functions. The third one, though, this one, what we did is we said, well, this point can be anywhere, right? This point can be anywhere, but if we fix it onto the unit circle, all the trig functions will still have the same values, but it makes the r equal to 1, right? And then it becomes nice, right? So here, we still take a point, but now this is 1, and this is still x, and that's still y, but then if you do that, and this is the key, if you do that, what is sine of the angle? It's the y coordinate. And what is cosine of the angle? The x coordinate, right? So this is what I want us to work with today. Sine of this angle, right? Sine of this angle is that distance right there. Agreed? So if I draw from here to here, that right there is the y coordinate, right? Ooh, this is bad marker. That's the y coordinate. But that's also cosine, sorry, I just did the wrong trig function. It is what? Sine of the angle, right? Similarly, the distance from here to here, that's the x coordinate, but that's cosine of the angle, right? Okay. So those are our three definitions. Today, what we're going to do is we're going to start graphing the sine and cosine functions. So what do we mean by that? Let me remind you of what a function is, all right? Or I know that you know what functions are, but let's just take this slow, all right? If I give you a function like f of x equals, let's say, x squared plus 1, right? This has a graph, doesn't it? We could draw this graph from college algebra. This is what kind of picture is that? It's quadratic, so what does it look like when I graph it? That bowl thing, the parabola, right? It's a parabola. And actually, that's a parabola, and then you add 1, it moves it up 1, right? But on top of there being a picture for this, right? There is a picture. This is what it would look like. On top of that, think about like a t-table for this, like old school. When we have x here and we have the function's value here, we can plug in values of x and it'll spit out, outputs, right? So if I plug in 0 in here, I get 1, right? If I plug in 1 squared plus 1 is 2. If I plug in 2 squared is 4 plus 1 is 5, right? And I could keep doing this, and if I go and plot these as points over here, 0, 1, that's there, 1, 2 is here, and then 2, 5 is up here. Got it, right? And we can create the entire graph with, are you laughing at my parabola? It's pretty good, I think. No, it's bad, right? But the points, right? The points can be represented here, right? And all the points together draws the graph. That's what we want to do right now for a new function that we're going to call the sine function. But we're going to run into a little bit of a problem here, all right? The problem is that in this picture, the x-coordinate here, right, that represents the x-coordinate of that point, right? And the y-coordinate represents the y-coordinate of that point. What I need you to see is, like over here, the x is the input, right? This is your input. This is your output. I'm going to create this new function called the sine function. The input is the angle, theta. Okay? The input is the angle. And the output is whatever sine of that angle is. So for example, if I wanted to do a table, okay? I'm starting to get into the sine now. I'm going to talk about the sine function here. I could create a table right now where the input is the angle, right? And the output, I want that to be sine of the angle. So if I do that, come back to this, and now think about your unit circle. If you have your notes, if you have a unit circle, I'm sure if you study for that quiz, you probably have a unit circle somewhere that you were referencing, right? If I ask you, what is sine of 0, what are you going to say? 0, right? Sine of 0, 0. And let's do this in degrees just to make this easy, right? What's the next angle you know? 30 degrees, right? So if I say, you know what, let's do radians. Let's do radians. I think we need to work with radians more. Isn't that pi over 6? Okay. What is sine of pi over 6? So 1 over 2, 1/2, right? 1/2? I'm going to write that as a decimal, just so we have it, okay? 0.5? What's the next angle that we're familiar with? What is it? Which one is it? Pi over 4, right? I'm looking at these common angles. We have the 45 here, there's the 30 degrees, there's the 60. So we already did pi over 6. Now we're doing pi over 4. And what's the output there? Root 2 over 2. What is that on your calculator? Can someone do that for me? What's root 2 over 2? Approximately 0.707? Do y'all get that? Yes? 0.707. So look, I mean, what we're saying here is that that first answer, 0, when we're aiming out at 0 degrees, right? The 0 that comes out is the height of that point, the height, the y-coordinate. When we rotate to pi over 6, our answer 1/2 is that height right there, right? That's 1/2. And then when we rotate to pi over 4, that height is what? How tall is this little dash line? 0.707, right? And now I'm going to rotate to the next angle. That's, what angle is this? Pi over 3. And what's the y coordinate there? What's that on our calculators? Approximately 0.866? Close enough, 0.866. Okay, what's our next common angle? The next one you should have known on your unit circle. Pi over 2, right? And what's the height of the point there? At pi over 2, what's sine of pi over 2? 1? Is that what I heard? Yep, 1. Is that right? So that y coordinate, that was 0.866, and then we got all the way straight up, and then that height was 1. Are we ever going to get past 1? Are the outputs on this side ever going to be bigger than 1? No, right? No matter what angle I go to, anywhere on this circle, the y coordinate will never go past 1. On the other side of that idea is that the y coordinate will never go past -1 down, right? So it looks like our sine function, right, whatever this is these answers are always stuck between -1 and 1. Do you agree with that? The y coordinates are always stuck there. Yeah? So out of all these outputs, right, all these outputs here, every answer we have here, which is the sine function, right, itself, those are all between -1 and 1. This is actually an extremely important inequality to know, that no matter what angle you ever plug into sine, your answers are always between -1 and 1. Does it make sense on the circle why that's true? If the sine coordinate is the y coordinate, if the sine function is the y coordinate on the unit circle, then you can't go past 1, you can't go lower than -1. So it's got to be bounded between there for any angle I ever give you, right? Y'all following this so far? We can keep going, can't we? We keep going. If we go around, I'm not going to do each one, but for each angle that we know of, we could go and just fill out that table, right? And fill it out. And then we would come back to 2 pi. And then wouldn't everything start over again? The table would just repeat itself again if I went around to my common angles? Yes? Question?
No, never mind.
You sure? So if I keep on going to my common angles, get to 2 pi, and then continue going around, 60 more or 30 more degrees and 45 and 60. If I keep doing that, the table just repeats itself. Yeah? Okay, so here's the part that I think is tricky, because we want to graph this. I want to graph this. So if I go to graph this, what I should do, what I should do is this. I should put this here. And this right here, this axis, I should call this my theta axis. Because isn't the theta the angle that's being put in, right? This is the input. And the output is the function itself, sine theta. So whatever goes in, if I plug in 0, it spits out 0. If I plug in pi over 6, spits out 0.5, and so on and so forth, right? But all the functions we've ever used in our life up to this point, what has been the input variable? What have we used? X, right? So theta is going to be a dummy variable here. We're going to replace the theta with x. And this is why I think this is tricky. I do not want you to confuse the fact that I'm going to call this x now and this sine x. I do not want you to confuse that with this x coordinate. What x means over here is the angle. It's confusing because it is. I mean, the x is now the input of the sine function, which is an angle, and it is not to be confused with the x coordinate on the unit circle. Do y'all see how that can be confusing? So just make sure you make that distinction in your mind that when I'm talking about x here, I'm talking about the input angle, not the x coordinate on the unit circle. Okay? So if I change this to x and this to x, we now have what we refer to as the sine function. It is a function of x, f of x, and we call it sine of x. And I want to know what it looks like. Okay, so I make my table, here's my table, and I start plotting my points. So how am I going to plot this? Well, I'm going to do that graph again over here. Here's one thing I know when I go to graph this. The outputs I know are between -1 and 1. So I know when I draw this, I never have to go past 1 up there and never need to go below -1. My graph is going to have to live between here and here, right? And then this x-axis are actually the angles that I'm plugging in, and those can be anything. But just for the sake of our first demonstration here, let's say imagine that that's 2 pi, so that's a full revolution. Okay, here's 0, and here's 2 pi. Halfway between those two would be what angle? Pi. And what would be halfway between 0 and pi? Pi over 2. And then this angle right there would be what? Halfway between these two. Think about your circle. If this is 0, that's pi over 2. That's 2 pi over 2. Isn't that 3 pi over 2 down there? So this is 3 pi over 2. Yeah? Those are kind of like the quadrantals, aren't they? Those are the quadrantals right there. And then it would keep going, but let's just start with this. Off of our table, what did we get when we plugged in 0 as our angle? The output is 0. So I'm going to plot this. We're actually going to start graphing the function. So at 0, we're at 0. Now, where are we at pi over 2? Well, I have a bunch of other angles in here, don't I? But here's pi over 2. So where am I? 1. That's up here. And then where am I at pi? What is sine of pi? We didn't put it on our table, but go back to this circle right here. If you're at pi, that's right there, isn't it? What is your y coordinate? What is sine of pi? Y'all sure? 0? -1? -1? We're talking about sine. Sine is which coordinate? Okay, at that point right there, what's your up and down? 0, right? So we should be at 0 here. Yes? What about 3 pi over 2? Now you're here. What's sine there? -1. Right? Here, that's 3 pi over 2. You're at -1. Are you all following this? That's down here. And then where are you at 2 pi? What sine of 2 pi? 0. Okay, so far those are the points we have, right? And that's what I know about the sine graph. Those points exist on that graph. The question is, what does the rest of it look like, right? So let's see if you can wrap your head around this. I think you can. Let's imagine just that we're just going to look between 0 and pi over 2. Right here. Think about what happens to the y coordinate. We're talking about sine, right? Think about what happens to the y coordinate as I start rotating from 0 degrees to pi over 2. Right here, the y coordinate is 0. Okay. Now, as I rotate around, what's happening to the y coordinate? It's getting bigger. So as I move to the right here, I should be going up, shouldn't I? The points are higher until I get here, and then I'm up here at 1. So the graph should do something like this, right? I think, something like that. Does that make sense to you? The y coordinate keeps getting bigger as I rotate. And then, once I get here, what starts happening to the y coordinate between between pi over 2 and pi, what happens to the y coordinate? It starts getting smaller, right? So it's going to do something like this. I'm just trying to eyeball what's happening. And then I do it again from here to 3 pi over 2, what happens to the y coordinate? What are happening? What are these numbers? They're negative numbers and they're getting bigger, right? Bigger negative numbers. So shouldn't that mean, or doesn't that mean that I move down? These numbers are getting bigger and more negative until I get to -1. That's straight down. And then as I rotate through, now the y coordinates are getting smaller towards 0, but they're still negative. So it should look something like that. Yes? I know that's going to be hard to see, but let's see if this helps. I think you probably get it, but see if I can make this a little bit smaller. No, why is that? What the heck? I guess that's it. So this is basically the same exact thing that we're doing right now. I'm rotating around, and what I'm doing, can y'all see that? I know this is kind of nuts looking, but here's my unit circle. Do y'all see that dotted red line? What I'm doing is whatever angle I'm at, here I'm at pi over 3, that's what's on the x-axis. Here's pi over 3. I know it's hard to see. And then however tall that line is what I'm plotting that point to be. And so as I rotate around, just notice that I'm just dropping that line off how high that is, and I'm leaving dots behind. Does that kind of make sense? And as I go around the circle, I get that picture right there. And then if you put all the points, all the angles in there and fill it in, you get your sine function. All right? So that's what the sine function looks like, okay? It is a plot where the input is the angle, right? The input is the angle, and the output is the y coordinate off of the unit circle. I'll say it again. When you look at the sine function, the input is the angle, and the output of the function is the y coordinate off the unit circle at that angle, right? Questions? What would happen if I kept going? What do you think this picture is going to look like if I keep going? Repeats itself, right? And actually, where would be my next end? Like if we call this one cycle of the sine, actually we call it the period, but if you think about it like a cycle, we start here, we come back to where we started. That's one cycle. Where would the next cycle end? 4 pi, right? So it would go up again, it would come down, go back up, right? That's what it would look like. So that's your sine curve. What about backwards? Can angles be negative? Yes, right? When you think about x, we've just plugged positive numbers in, but could you plug, or sorry, we've just plugged positive angles in, but can we plug negative angles into the sine function? Sure, right? It would just be a repeat. I mean, it's just draw this picture but go backwards. What is what would happen, okay? And it goes in both directions forever. You can go this way forever, you go that way forever, all right? So if we have this sine function, f of x equals sine of x, I want to just state a few properties of it. First of all, the domain of this function. What does domain mean? The things that you're allowed to plug into the function. When it comes to what's being plugged in, the input of a sine function, it's an angle. And that angle can be any number we want, right? There's no restrictions. It can be any positive number, any negative number. There's no restrictions. So that means my domain is everything. How do I say that? How do you say everything? There's a couple of ways you can say it. One way you can say it is all real numbers. You can actually write that down, all real numbers. What's another way I can do it? I can write in interval notation, negative infinity to infinity. And there's another notation. Yeah, like a capital R. It's called a double struck R. This means all real numbers. This means all real numbers. This means all real numbers. It means that these all mean the same thing. I don't care which one you use. Actually, I kind of prefer that or that. But, you know. So this says that for the sine function, you can plug any number you want into it, right? Now, what about the range of the sine function? If domain is what goes into the function, the range is the outputs. So is there any sort of restriction on the outputs of this function? Negative 1 to 1, right? So I'm going to put here in interval notation, bracket negative 1, parenthesis, comma, sorry, positive 1. This is the range of our sine function. The things that come out of the sine, right? The things that come out the other side of the function are numbers between negative 1 and 1, right? Nothing at all bigger than 1, and nothing at all smaller than -1. So, let me ask you this. If sine, I'm trying to get ahead of ourselves a little bit. If sine of some angle, I'm going to say x. If sine of some angle x equals 1/2, and I tell you that that x is between 0 and 2 pi, can you find me the x that I'm talking about? Yeah? Can someone explain what this is asking? Like, can you explain in words, help the rest of the class explain what it is I'm actually asking you to do? Find the angle. Find the angle that when you look at the unit circle, the point for that angle has a y value of 1/2. And that the angle is between 0 and 2 pi, which means it's a positive, so you're only allowed to look in the first rotation. Do you have an idea where that is?
30 degrees.
Yeah, so what I would do is this is where I'd start visualizing my unit circle, right? And I'm sitting here, I'm going, okay, this is asking me to figure out at what angle, or angles, there could be more than one answer, at what angle or angles is my y coordinate on the unit circle 1/2. And I'm thinking y coordinate why? Because we're talking about sine, right? So I go over here and I look, where's the y coordinate 1/2? Well, I have to just remember this, right? Isn't that right here? That first one right there, right? The y coordinate was 1/2. I'm not even going to write the x coordinate. I don't care about, I mean, I know it's root 3 over 2, but what I'm interested in is the y coordinate, right? And what angle is that? Pi over 6, right? Or 30 degrees. So that's one answer, right? X is pi over 6. But is that the only answer? No. There's another one where? 5 pi over 6 over here. Right? So this right here is pi over 6. This right here is 5 pi over 6. So that would be a second answer. Are there any other answers between 0 and 2 pi? No, there's no other places where your y coordinate is 1/2 other than those 2 points. Make sense? Next question I'm going to ask. You sure there aren't any questions? How about this? If sine of x equals 2, find x. So what am I asking you here? At what angle on the unit circle is your output? What's equal to 2? What? The what? The y coordinate. Okay, again, we have to make sure we're being precise about this. This is saying at what angle on the unit circle is your y coordinate 2? I see some no, right? That's not going to happen. That's never going to happen, right? You're on the unit circle. Look, you can only go out 1. And didn't we say the range of the sine function is between -1 and 1? So what's the solution to this? There is no solution. There's no solution to this equation, all right? All right. You all ready to look at the cosine function? So if the sine function is giving you the y coordinate on the unit circle at the angle x, then the cosine function will be giving you the x-coordinate on the unit circle at the angle. So we said f of x equals sine x, right? This gives you the y-coordinate on the unit circle at the angle x, right? That's what that does. So the cosine function, f of x equals cosine x, will give you the what coordinate? The x coordinate on the unit circle at the angle This is what I was warning you about. We're using x twice. This is why this is confusing the students. On the unit circle, we have an x coordinate, right? Any point on the unit circle, we have an x coordinate and y coordinate, and then we call this angle theta. And we know that the x coordinate is cosine of theta. But when I go to graph the cosine function, I want to use x as my input for the angle. So when we say this is always going to give us the x coordinate on the unit circle at the angle, well, what angle are we plugging in? This x. See, they're not the same x's. That's what I'm trying to get you to see. They're two different x's. One of the x's is the x coordinate on the unit circle. The other x over here is the angle being put into the function. So it's confusing the students. And that's why I'm trying to really stress it, okay, at the angle x. Okay, but that angle is actually this. We stop thinking about that as theta. We call it x, but these two x's are not the same. It's confusing. All right, let's talk about what would happen if we made a table for this. If this is x and this is cosine of x, let's think about the unit circle. Let's start at the angle 0. What is cosine of 0? So you should be thinking, okay, you should see your unit circle, right? You see it? And then you should be thinking angle 0. And you should be thinking, what's my x coordinate out here? 1. Right? Then you say, okay, what's the next common angle I have? Pi over 6, right? So now you're looking at your unit circle. Pi over 6 is like right there, right? And you're saying, what's the x coordinate, right? Because you're talking about cosine. And what is it? Root 3 over 2. Which is about 0.866, right? Now the next common angle, pi over 4. You come up, right, to 45 degrees. And you're looking for the x coordinate, which is root 2 over 2.